In this lecture, we're going to go through the calculation of a single predictor regression analysis using SPSS. And so we have our data entered into SPSS, and I have score and study, or the hours of study, and the score, which is the outcome on a test, for our 100 cases here, our 100 research participants. And in this study, score will serve as the criterion variable or the outcome variable of interest, and we're going to examine if the amount of hours spent studying can be a statistically significant predictor of score. And we're going to do this through the regression analysis. Now, to do this, we're going to go up to Analyze. It's going to click Analyze, and we're going to scroll down to Regression. You see we have a lot of different options here, but we're going to carry out a linear regression analysis. So we'll just click Linear. And we have a lot of options here, but since we only have a single predictor, we only will be using a few of these. So score, which is the item of interest, we're going to highlight this one, which is already highlighted, and we pull this over to the dependent category. Now remember, in a correlation and regression analysis, the outcome variable we typically refer to as the criterion variable, but in SPSS this is identified as the dependent variable, which makes study, or the number of hours spent studying, our predictor variable that SPSS refers to as the independent variables. This is our predictor. And we don't have any other predictor variables, so we just leave it as such. Now we'll go up to Statistics, and we want to click, there are many items here, but I'm just going to click the R-squared change for the adjusted R-squared. That is a mathematical adjustment for the number of predictors, but we only have one predictor, but there is still going to be a slight adjustment to it. And we'll just go ahead and click the descriptives, and that'll generate descriptive data for each of our two variables. And we'll just continue. And then there are a number of other options if you want to generate plots, but we're just going to go ahead and just run the regression analysis here. So I'm going to hit OK. And here we see our output. So at the very top we have our descriptive statistics in terms of the mean and the standard deviation for our 100 cases. And now we have a correlation table, and this was something that we did with the correlation analysis. So we'll scroll down to the bottom here, which is the outcome of our regression analysis. So we have our ANOVA table. So this is what we always report with a regression analysis. And so what we see here is a very large F value and a correspondingly very small p-value, indicating that the predictor variable is statistically significant in terms of predicting the outcome. What we also have here is our regression table, and the regression table will give us the R value, so that's our correlation coefficient, the R-squared value, which is the coefficient of determination, the adjusted R-squared value, and the adjusted R-squared value is always going to be a lower value than the R-squared value, and this is a mathematical adjustment for the number of predictors in the model. And now we have our standard error of the estimate. So if we predict, or if we attempt to predict the score on a test given a hypothetical number of hours studied, the model will give us a predicted value, and that predicted value will lie within plus or minus the standard error of the estimate. And then we scroll down to the bottom for our coefficient table. And our coefficient table are the values that we use to build our regression model, and this is a linear function, essentially y equals alpha plus beta x, where alpha is the y-intercept and beta is the slope. And so the y-intercept is given with our what's called an unstandardized b, 52.153 in the units of our measurement, and the study is the study unstandardized coefficient that you see here, 1.958, is the slope, so that for every unit increase in the number of study hours, the outcome is predicted to increase by 1.958 units. Each of the unstandardized coefficients will also have an associated standard error. And we can see here that the calculated t-statistic for each of these separate coefficients were found to be statistically significant, indicating that our model is a significant predictor of score on the test given the predictor variable of the number of study hours, and the strength of that relationship, often referred to as an effect size, is quantified in the r-squared value. So this ends this video on using SPSS to generate a regression analysis.